Space Exploration Technologies Corporation, or SpaceX, was founded on March 14, 2002, a date that marked the beginning of a period that will forever change the face of travel and brings it to new heights with commercial space flights. This new era brings the human race to a futuristic projection of interplanetary colonization and ambitions of intergalactic travel in hindsight. We have certainly come a long way from Apollo. With SpaceX engineer and founder Elon Musk's vision, it's hard not to get excited about the endless possibilities that we once thought were beyond our wildest dreams. But is the future really finally here? Before we take you to an exciting walk down SpaceX's memory lane in today's video, if you're fascinated with space news and want to get the latest scoops on groundbreaking events and advancements, then you've come to the right place. Please subscribe to our channel, like and share our videos, and don't forget to hit the notification bell to keep you updated. Today, we're going to walk a few steps back into the humble beginnings of SpaceX and see for ourselves how far we've come in just a few years as the world watches this revolutionary plan come to fruition. How close is the human race to becoming a multi-planetary species? Back in 2006, SpaceX entered the arena of space travel with Falcon 1, finally pushing through with its inaugural launch attempt from the Marshall Islands on March 24th of that same year. Falcon 1 was a two-stage liquid-fueled rocket designed to send small satellites into orbit. It uses SpaceX's very own Merlin, a self-developed LOX kerosene rocket engine considered a cheaper alternative to what most companies use, which lends to its cost-effectiveness. SpaceX planned to build a relatively simple 21.3 meters tall, 1.7 meter diameter kerosene-fueled two-stage rocket capable of boosting about 0.6 tons to low Earth orbit. The company focused on providing the lowest launch price possible. The March 2006 launch failed and blamed its premature success on a fuel leak and fire that was said to have started 400 seconds after takeoff. However, this defeat was not the end of SpaceX. Our journey to the future continues as SpaceX won that same year a NASA competition, earning funds to build and demonstrate spacecraft that can potentially service the ISS. Following that side win, just a year after its first launch, SpaceX set out to another attempt in March 2007, followed by another in August 2008. All of its first three attempts have unfortunately failed. Yet, despite moving forward with failure after failure, SpaceX persevered until finally, the winds of change blew on September 28, 2008 with its successful fourth flight. Falcon 1 became the first privately developed liquid fuel rocket to orbit the Earth utilizing SpaceX's Merlin 1C rocket engine. Falcon 1 achieved an elliptical orbit of 500 kilometers by 700 kilometers, 9.2 degree inclination, exactly as targeted. In addition, it carried into orbit a payload mass simulator of approximately 364 pounds, designed and built by SpaceX specifically for this mission. The payload, consisting of a hexagonal aluminum alloy chamber 5 feet tall, remained attached to the second stage as it orbited Earth. The 2008 attempt was the fourth launch of the Falcon 1 and the second flight for the new SpaceX-developed Merlin 1C regeneratively cooled engine. What follows after is a series of postponed launches until Falcon 1's last flight on July 13, 2009. 38 minutes after placing Razaksat into its initial parking orbit, the rocket's second stage engine fired again to circularize the orbit, with payload deploying after that. The Falcon 1 upper stage is still in low Earth orbit as of 2021. The vehicle was decommissioned from services after that. Dubbed as the first orbital class rocket capable of reflight, Falcon 9 is a two-stage launch vehicle powered by liquid oxygen, or LOX, and rocket-grade kerosene, or RP-1. Since June 2010, rockets from the Falcon 9 family have been launched 143 times, with 141 full mission successes, 1 partial failure, and 1 total loss of the spacecraft. The first-stage propellant tank walls of the Falcon vehicles are made from an aluminum lithium alloy. Tanks are manufactured using friction stir welding, the highest strength and most reliable welding technique available. A common dome separates the LOX and RP-1 tanks, and a double-wall transfer tube carries LOX throughout the center of the RP-1 tank to the engine section. 4 grid fins near the top of the first stage and 4 deployable legs at the base are nominally flown to support recovery operations. 9 SpaceX Merlin engines power the Falcon 9 first stage with up to 854 kN thrust per engine at sea level for a total thrust of 7,686 kN at liftoff. In addition, the Falcon design features reusable first-stage boosters which land either on a ground pad or on a drone ship at sea. Falcon 9 was updated in the summer of 2015 to a full-thrust configuration from its previous version 1.1 configuration, which was flown from 2013 to the summer of 2015. In December 2015, Falcon 9 became the first rocket to land propulsively after delivering a payload into orbit. This achievement significantly reduced launch costs. Falcon family core boosters have successfully landed 106 times in 117 attempts. A total of 29 boosters have flown multiple missions, with a record of 11 missions by the same booster. Falcon 9 underwent further updates and first flew its full thrust Block 5 configuration in spring 2018. The first rocket, Falcon 9 version 1.0, was launched 5 times from June 2010 to March 2013. Its successor, Falcon 9 V1.1, 15 times from September 2013 to January 2016, and the latest upgrade, Falcon 9 Full Thrust, 120 times from December 2015 to the present. Falcon 9's typical missions include cargo delivery and crewed flights to the ISS with the Dragon and Dragon 2 capsules, the launch of communication satellites and Earth observation satellites to geostationary transfer orbits and low Earth orbits, some of them at a polar inclination. The heaviest payload launched to an LEO is a batch of 60 Starlink satellites weighing a total of 15,600 kilograms or 34,400 pounds, which SpaceX regularly flies to roughly 290 kilometers or 180 miles orbit. The world's most powerful rocket, Falcon Heavy, is a 2-stage heavy-lift launch vehicle powered by LOX and RP-1. It can transport more payload mass into LEO or GTO than any other launch vehicle currently in operation. Falcon Heavy is the most powerful launch vehicle in the process, with more than 5.1 million pounds of thrust at liftoff. It builds on the proven, highly reliable design of Falcon 9. Falcon Heavy's first stage comprises 3 Falcon 9 first stages, with enhancements provided to strengthen the cores. Furthermore, Falcon Heavy utilizes the same second stage and payload fairing as flown on Falcon 9, fully benefiting from the flight heritage provided by Falcon 9 flights. Falcon Heavy comprises 3 Falcon 9 9-engine cores, whose 27 Merlin engines together generate more than 5 million pounds of thrust at liftoff, equal to approximately 18 747 aircraft. It is the most powerful operational rocket in the world by a factor of 2, with the ability to lift into orbit nearly 64 metric tons or 141,000 pounds. Falcon Heavy can lift more than twice the payload of the next closest operational vehicle, the Delta IV Heavy. The Falcon Heavy is part of the privately developed family of 3 Falcon launch vehicles, with Falcon 1 and Falcon 9. SpaceX first launched the Falcon Heavy vehicle on February 6, 2018. On its demonstration flight, Falcon Heavy successfully lifted off, carrying a Tesla Roadster into space with a dummy-dubbed Starman in the driver's seat, its dummy payload. The second Falcon Heavy launch was on April 11, 2019, where all of its 3 booster rockets successfully returned to Earth. The third and last launch, by far, was also a smashing success, which took place on June 25, 2019. Since then, Falcon Heavy has been certified for the National Security Space Launch Program. SpaceX's Starship represents a fully reusable transportation system designed to carry crew and cargo to Earth orbit, the Moon, Mars, and beyond. The 2-stage vehicle comprises a super heavy rocket booster and Starship spacecraft powered by subcooled methane and oxygen. Starship will be the world's most powerful launch vehicle ever developed, with the ability to carry more than 100 metric tons to Earth orbit. In addition, the Starship can transport satellites, payloads, large observatories, crew, refueling tanks, and cargo to various orbits and Earth, lunar, or Martian landing sites. Starship's main features are its high payload, mass capability, and low potential operating cost. A tanker variant spacecraft is planned that will refuel other Starships in orbit, increasing the 220,000-pound transport range to higher energy orbits and destinations, including the Moon and Mars. The earliest Starship variant will deploy satellites, while later variants will also serve space tourists or be optimized for lunar landings. Starship's potentially low cost is key in enabling SpaceX's Mars ambitions and making point-to-point rocket travel on Earth possible. SpaceX first outlined the rocket as early as 2005, with frequent design and name changes as the concept matured. In July 2019, Starhopper, a prototype vehicle with extended fins acting as fixed landing legs, performed a 150-meter or 490 feet low-altitude test flight under the power of a single Raptor engine. In May 2021, Starship SN-15 successfully flew to 10 kilometers or 6 miles, transitioning to horizontal freefall before successfully landing for the first time after 4 failed attempts by previous prototypes. As of February 2022, the BN-4 booster and SN-20 spacecraft are scheduled for the first full-stack flight in early 2022, though this schedule is subject to change. With all that's been discussed in today's video, there is no wonder that the human species is coming closer to the future one day at a time. The future is near, and more so, maybe, just maybe, the future is here. It will only be just a matter of time when going to the moon or Mars is like taking a summer trip to Paris, and instead of seeing the Eiffel Tower, we'll see large cities and civilizations on Mars like the ones always depicted in sci-fi movies. What's certain is that this quest for the evolution of the human species, a multi-planetary kind, is making the rest of the world both anxious and excited. How do you feel about this? Share what you think in the comments below. Whether or not this ambitious vision manifests into reality in our lifetime, there is no question as to the wonder and inspiration it brings to today's life. One other thing we're sure of is that Gen Z Tech will be on the lookout for the latest updates on the progress of SpaceX as we watch the future unfold right before our very eyes. So that's it, Gen Zs. That's another one of our shorts on the ever so fascinating spacecrafts and out of this Earth voyages.